Hello everyone, my name is Amy Berry, Strategic Account Manager for Applied Software, and I want to thank you for joining us for today's webinar, Machining Made Easy with Inventor HSM. This is brought to you through our live lab learning, which was created to provide world-class training to design and engineering professionals. I'll place everyone on mute, but we encourage you to interact with us by posting questions and comments in the question pane to the right of your screen. We will answer questions at the end of the presentation. We are recording today's session and will make the link available for everyone soon. To start things off, I'd like to give you a quick overview on the company behind the product, its contributions to the CAM industry, and a brief overview of the product's approach to machining with integrated CAM. By the end of this last year, Autodesk will have invested more than $250 million in the CAM industry. That's billion with a B. In 2012, Autodesk purchased the HSM for best-in-class integrated CAM, and you may not know this, but last year they acquired the best in standalone CAM solutions, Delcam. We can now say that Autodesk has a solution for everything from design all the way through manufacturing. Based upon their high-speed machining kernel, there are 3 product choices for our customers. There is Express, which is full 2.5 axis milling, Professional, which includes 2.5 axis milling plus 3D milling, 4-axis, and turning, and Premium, which includes everything in Professional plus multi-axis milling. Each package offers customers flexibility in pricing and a number of nice extras not typically found in legacy CAM systems. This includes an open API, access to more than 75 post-processors, adaptive clearing, and a number of tool libraries. In addition, the product levels are not modularized. We don't nickel and dime you, and there are options that allow you to leverage integrated CAM regardless of your budget and machining needs. We have the free Express product, and in the case of our Professional and Premium versions, you will receive a copy of Inventor. Also, in addition to the perpetual licenses most of you would be familiar with, we also offer the term-based option, kind of a pay-as-you-go if you're trying to save upfront capital for other investments. So why choose an integrated CAM solution? This is key. According to the July 2013 SIM data report, the fastest growing segment in CAM software solutions is integrated CAM. This integrated CAM leverages the existing investment a company makes in their CAD tools. Because of this, the typical 8-step machining process, as you see across the top, and of course the 16-step machining process, where an ECO is involved, is greatly reduced when the CAD data is leveraged. We had a customer recently tell us he has reduced the time spent on jobs by roughly 60%. And I'm hearing stories every day about how easy it is to use HSM. Spoke to someone the other day who said he learned in 2 hours what it took him 3 days to learn in another CAM system. So reducing the steps to updating CAD data, regenerating and validating the toolpaths, and posting your code allows the NC programmer or design engineer to take control of the NC programming process. Many downstream benefits include ETO automation, streamlining communications between departments, true work group collaboration, engineering change order accuracy, and even faster turnaround time. So Applied Software has partnered with Technic Group to bring best-in-class services to our manufacturing customers. They are certified by Autodesk as one of only 5 master resellers in North America for the HSM CAM products. Applied Software selected Technic due to their technical capabilities for our customers and their close relationship with many of the machine companies such as Morisiki, Haas, Sandvik, and many others. As partners, we provide full implementation services from installation to automation, as well as training to help our customers reach the full value of their Autodesk software purchase. Speaking of technical expertise, I'm going to now turn it over to Matt Nichols to start the demo. And in the process of him doing that, I'm going to take a quick poll. We would like to know if you're interested in 2.5 axis, 3 axis, or the full multi-axis. Okay, I think I will, the poll is, well, 67% voted. Who else is out there? Give you about 10 more seconds. And I'm going to close the poll. With that, Matt Nichols, take it over.
All right, thank you, Amy. Good afternoon, everybody. So today in our demo, we are going to do a brief overview of some 2.5 axis application, show a couple of tips that you may not know, and then we'll move into our 3 axis demo. So first, starting with our 2.5 axis, I've got these couple vices set up with parts, and I've already got my setup for one of these parts. So let's go ahead and start roughing this part. So first I'm going to start with a face strategy. I'm going to come in and select my 2-inch face tool. And then I'm going to hit OK and let the toolpath generate. And I'm going to come in and do 2D adaptive. Again, I'm going to come into my tool library and I'm going to pick a 3/16 flat end mill. Now with this, I'm going to come to the Geometry tab, and I want to pick the faces of these pockets in the part. Then I'm just going to hit OK and let the toolpath generate from my selections. And then with that, I'm going to come in and I'm going to create a derived operation with that same 2D adaptive. And the good thing about this is if you have any tools that you set up special feeds or speeds for, this will copy those modified entries into the next operation where we're going to rough the outside of the part. So I'm going to come to my Geometry tab. Notice that the inside of the pockets are still selected. I'm going to clear that. I'm going to come out here and I'm going to select the outside of my geometry. And then just going to hit OK. Then I'm going to come in, I'm going to do another derived. I'm going to do a 2D contour just to finish the outside of that and get a smooth finish. And all I have to do here is hit OK again. And then
Hey, Matt, this is Amy. I was just going to, I hate to interrupt, but I just wanted to make a point that you're running the CAM solution inside of the CAD solution, correct?
Correct. This is within inside Inventor.
Correct.
All right, and so then next I'm going to move in, and this is where our first unique tip is going to come up. I'm going to drill out these holes. So first I'm going to come in my drill operation, and I'm going to start with a chamfer tool. That way I can spot the holes for my drill operation. That will be next. So I'm going to come in, I'm going to select the cone of the hole, and then I'm going to also select same diameter. So then it'll pick up automatically all my other holes. I'm going to hit OK. And then I'm going to come in and do a drill again. And this time I'm going to pick my .136 drill. I'm going to come in, I'm going to select the inside of the hole, And I'm also going to select same diameter, so it'll pick up the rest of them again. Alright, so with this, if you have a part that would use that same setup typically, I can come in, I can select my toolpaths, right click, and I can store the template. So we'll just do this spot drill. So then if I came over and I did a setup on this part, I could automatically use that template and generate those toolpaths on that part without having to redo all my settings. And then, so then this leads to our next tip. With this setup on this part, notice I've got a mirror part on the same vise. So we're going to do a pattern on our toolpaths. So I'm going to create a mirror pattern. We've got this plane set up, and I'm going to say in the operation order, I'm going to order by tool. So that way whenever you generate the post for this, it'll do all the operations with the same tool before going and changing out bits. So then I've got that mirror set up. I'm going to just drag all those underneath my pattern, and I'm going to simulate this so you can see that it automatically generated all the tool paths on that mirrored part. So that was a quick overview of what we do with some of the tools that you can do on the 2.5 axis. Are there any questions maybe out there right now?
As a reminder, you can post your questions to the right side of your screen in the question panel. Please note that this is everything you saw in that presentation was 2.5 axis milling, which is actually the Express free version. And with that, I see no questions. So we'll move on to 3-axis milling.
Okay, so on this 3-axis, I've got my part set up on a fixture. So I'm going to come in, I'm going to create a job setup, and I want to pick my stock point, just place it right there in that corner, and then I'm going to come over here into my stock tab. I'm going to say no additional stock. I'm going to click OK. So now we've got this part set up, and we're ready to start roughing out the part. So first I'm going to come in, I'm going to create a 3D adaptive clearing toolpath. I'm going to come in and I'm going to select 3/8 inch bull nose end mill. And I'm going to make sure that my tool doesn't go outside the boundary of the part. I'm going to click OK. Notice that while it's calculating, and it's already done, now I'm going to simulate this toolpath with the stock. So you notice that adaptive clearing was capable of taking very deep roughing cuts. So the second fine step down was used to get in closer to the model. So we're going to go ahead and close that, and I'm going to go back and I'm going to do another adaptive clearing. This time I'm going to go with a 3/16 bull nose so that we can get a finer cut down onto the part. And then I'm going to go over to my geometry tab, make sure rest machining is on, and I'm going to pull this down and do from previous operation. And while that's generating, I'm going to start a contour toolpath. With this one, I'm going to come in, I'm going to create a 1/4 inch ball, and on my geometry tab, I'm going to make sure I have center selected. And with this one, we're going to cover, on the contour, we're going to cover from 30 degrees to 90-degree angle. And on this one, we're going to leave rest machining off just to see how it'll turn out. So notice with that toolpath generated, it's got everything from 30 to 90 degrees mills. And then notice while I was doing the contour toolpath, my adaptive clearing also finished generating. So now with those, we're going to go on and we're going to get this smaller degree cuts. So with that, we're going to do a parallel. Again, I'm using the 1/4-inch ball. Make sure my tool center, or my tool containment, is on center. And here on the slope, we're actually going to do 0 to 35. And this will give us a 5-degree overlap in our tool paths. I'm going to come in, I'm going to hit OK. So notice with this tool path, it ended up cutting on the top of the part, which we're not wanting. And the step over is just a little aggressive. So we're going to come in and we're going to edit this. First, I'm going to address the height. So I'm going to change the top height to be negative 0.125. So that way it won't recognize the top of the part. And then I'm going to come over and I'm going to make my step over 1/10 of the diameter of my tool, so 0.025. And I'm going to change the path direction to 45 degrees to make the tool path more efficient on walls that are perpendicular to each other. With that, I'm going to hit OK. So now notice that it's contained to 0 to 35, and the step over is much finer than what it was previously. And this will give us a nice smooth finish. So now the last thing I have to do on this part is to cover these radiuses that haven't been touched by any of the other tools. So with that, I'm going to do a pencil command. And my tool of choice on this one is going to be a 16th-inch ball nose end mill. And we're just going to hit OK and see what it generates. Okay, so you'll notice that it's gotten the smaller radiuses, but I've got larger radiuses that haven't been touched. And we want to do a little bit of a finer finish on these, so we're going to come in and we're going to edit. On the Passes tab, so for the larger radiuses, I'm going to add an over thickness of 0.125, which will include our radiuses on these edges. And then on the step over, I'm going to do 0.0025. And I'm also going to change it to an 11 step overs. And then with that, we're going to hit OK and see what generates. So notice now we've got a lot smoother finish will be machined on this part with the step overs. All right, so that finishes our generating tool paths on this part. So now let's do a simulate to see how it compares to our stock. And on this, I'm going to turn off tool path so you just see stock. All right. So now we did that, and now we're going to go in and post process. So with this, I'm just going to use a generic cost that's already in the program. And we're going to do our program name is 1236. And you'll notice over here that there are also other optional properties that may be unique to your machine that can be triggered with different variables. but we're not going to
So
change any of that right now.
So when you say that is part of the system, it's one of the 75 post processors that are included?
Correct, and I'll do this pull down so you can see the number of posts that, and these are all standard with our free version as well. So notice there are quite a few options. Yeah. So then we'll go ahead and post with that. Save, and so our post will open up in our post editor. So you'll notice that in this post there are color coding on the text. So the red color coding is for rapid movement. The green is for lateral movements, and then blue is for I forgot that one. I think for longitudinal movements. Anyways, so one of the unique features that is in with our editor that a lot of people really love is this backplot window. So it'll actually simulate through all the coding and show you in the window how the machine will cut.
And Matt, just to clarify, I believe you said this a second ago, the editor is available with the free 2.5-axis version, which then can be used by bringing in, basically you could bring in code from even other CAM solutions to be able to generate what you just showed, correct?
Yes.
Just re-emphasizing that.
There we go. So now you can see it runs through the code and shows the machining of the part. And that completes our part of the demo.
There is a question, but I think we may have answered it. Regarding the editor, does that have to be exported to a notepad or anything, or is this all with the software?
It is all with the software. If you want, you can open it up in a notepad document, but the editor is standard with any of the HSM.
And the editor is actually where you can see the color coding as to what is what, correct?
Correct.
Gotcha. A couple other things to point out. We showed the 2.5-axis. He's shown some 3-axis milling. One of the key of integrated CAM is that the workflow that can be done between engineering and manufacturing. So if changes were made to the part within engineering, they're automatically going to back workflow forward to the manufacturing portion of it. So it streamlines the work process, as well as all the solutions come with data management, manage both the CAD and the CAM solutions. So not only are you tracking changes to the design, but you can also track changes, pardon me, changes to the CAM programs as well.
And I'll kind of show. Say I take out that part of the block, I can come back in and just do a regenerate of all the toolpaths. So now you'll see like so you see how it regenerates and recognizes that that one feature is gone.
Perfect. I'll remind you that you can ask questions in the question tab to the right. Let me see, there may be another one. There's a question. I see the word adaptive a lot. What does that mean?
So adaptive clearing with HSM is the ability to remove material in a very fast fashion. It calculates the most effective way to use the maximum amount of bit to remove material in the shortest amount of time.
Okay. Let's see if there's any other questions. I'm going to give about 1 more minute for questions, and then we'll wrap it up.
Julie.
There is another question. Did I hear Inventor is included with the ThreeAxis?
Yes,
the answer to that is yes, it is. So you have a full CAD and CAM solution together with one maintenance renewal that maintains all both your CAD and your CAM. Next question, is the adaptive clearing feature available in 2.5 axis as well?
Yeah, if you look right here on this 2D milling panel, 2D adaptive.
Okay. Last chance for questions. Going once, going twice. Matt, why don't we switch over to the final screen?
Okay.
So what are some of the next steps? First of all, I would love for you to check out our Live Lab Learning website on either YouTube or on Facebook. And then our website, with that, it'll link you to our website where it has tons of instructional training and free webinars that are available on a monthly basis as well. Next slide. So what are your next steps that you might want to consider? If you haven't already done so, I strongly encourage you to download the free Express version, especially if you're paying for 2.5 axis software today. Or if you'd like a personal or more in-depth look at the products, please get with me to arrange for one. And of course, we can set up for a trial version as well. Here on the screen, the bit.ly is a link that you can type in to get to general information about all the products and information. And then you can email manufacturing@asti.com. It will then be forwarded to the appropriate sales rep in your territory, or feel free to reach out to us at the 1-800 number listed there. Again, thanks for sharing part of your day with us. We appreciate each and every one of you, and we hope to hear from you soon. Thank you.